In this next video, we would talk about RAG, which stands for Retrieval Augmented Generation. So before I show you the demo, I would briefly talk about how RAG works um, and why it is useful. So if you remember in one of my previous videos, I talked about the cutoff date for LLM. Now, if you need to give the current context, one way to give that is through RAG. So basically, you create a local database and the current context, your uh, recent documents or some info that you want to feed to the LLM. So that you can do through this process. Because in this scenario, what happens when you put a query, the agent would basically go to the local database to fetch some relevant information, and then only along with the query that information will be fed to LLM to create the final response, right? And that way you can also do a local implementation if you have documents which is very particular to your account, which you don't want to share with others or give access to internet. So you can locally implement RAG, right? So in this implementation, what we have done, we have taken a document of around 2,300 pages, PDF document, and that has been split into multiple chunks. So that size you can define in your coding. In this case, we have given the token size as around 1,000, which comes to around 1 page roughly. So this whole document of 2,300 pages has been chunked into split into multiple chunks of around 2,300 chunks. And that has been then using an embedding model, which we have used Hugging Face embedding in this illustration, has been converted into a vector and then saved in a vector database. Yeah. Now, on the other side, what happens when the user is asking a query, then using the same embedding model, and this is very important, the embedding model that you use here for embedding the query and the embedding model that you use for originally uh, vectorize your document has to be same. Yeah? Otherwise, this is not going to work. Now, using the same embedding model, you convert your query to a vector, and that vector is then, so we look for similarity, or this is called similarity search, and you can put a parameter out there. There is a factor called k matches. So basically you tell the, here that how many matches you are expecting, right? So for example, you are putting the number as 3, then you basically telling that return me the 3 chunks which are closest to your query. If you put this parameter as 5, then you are basically telling that return me 5 pages, because here your chunks are almost like 1 page, which are closest to the query that you are asking, right? If you put the parameter as 1, that means you are basically asking the vector database to return only 1 page, which is closest to your query. Now, what happens at this point in time? So here you see the query goes like that. Your query gets embedded. Queries, then it checks for similarity search, and then if the number is 3, then 3 documents will be coming back. Now, at this stage, what happens is that the LLM is fed with your original query in the original format. It is not the embedded one. Your query is now going to the LLM along with those 3 chunks, right? Because you have put the parameter as 3. So it would go here, and the LLM would then look for the answer only in those 3 documents, vis-a-vis searching it in a document of 2,300 pages. Here it needs to search for the answer only in those 3 pages for that query. Hence, it would be very fast, and then the LLM would get the answer. Uh, then the answer would be then send back to the user. So LLM would take the responsibility of articulating the answer and sending it back to the user. So that is in a nutshell how RAG works. So let me then go back to our model and show you an example. So in this case, the 2300 pages document that I talk about. So I downloaded the PDF version of Mahabharata. Took a very simple example so that people can easily relate to. Now that Mahabharata document has been split into 2300 pages and has been vectorized to a vector database, and ChromaDB is the database that we have used in this demo, using that Hugging Face embedding that I mentioned earlier. Now, if you ask a question, anything on Mahabharatas, for example, uh, between whom the war was, say, fought. So let's see if it can answer that query. So it is saying that war was fought between Pandavas and between the Kurus, right? Pandavas and Kurus. So it is being able to answer that question. Let's then ask another question. Say, who is Karna? Yeah, so here we get the answer. So it is being able to fetch this data from the PDF document about Karna. Now, one thing I like to highlight is that since this model would always go to the PDF document and answer only from the document. So if you ask something which is not there in the document, this model RAG cannot answer that query. For example, if you ask, where is Bengaluru? So let's see. So this information, it would say that this information is not found in the RAG document, and hence it cannot answer. So it is not going to go to internet to get the data and so on and so forth, because it's a RAG model. Then you have strictly instructed to give the answer response only from whatever document you have locally uh, stored in the vector database. And in many cases, even if you do not have, once you implement the RAG model, you don't even need internet access, because it is running all locally on your local network, right? And that is where it becomes very useful for the kind of work that we do. For example, if you are querying a KEDB database, you vectorize your whatever format you have the KEDB, maybe you have it in an Excel, you convert it to a vector database, and then now you are querying against your KEDB. So it would always respond only from the KEDB document, not from anywhere else, right? You don't go to the internet to fetch the data. It would only refer to your local document, and then LLM is used only to articulate your response, right? So that is how RAG works. So this is a demo for that. So I'm stopping this demo here. See you in the next video, where we will talk about agents.